5.2 number 6, you're supposed to fill in some of these blanks, and there are definitely a couple of ways that you can handle this. So they started with this and they moved to this because tangent is sine over cosine, cotangent is cosine over sine, and then so you can see they wrote them in terms of sines and cosines over sines. Now you could take this and multiply by its reciprocal kind of thing, or you could get common denominators on top and common denominators on the bottom, and there's some work there, but I'm just going to look at this problem and say, all right, let's start on the bottom. On the bottom, they say it's sine squared plus something. Well, to get to the next step, what would have to go in the second blank? So sine squared plus what would give me a 1 down here. And so if you went and looked at your Pythagorean identities, what would have to go in this blank right here? And then on the top, if this is sine squared and this is sine squared, then this blank is given to you right there. So instead of working it from the top down, I actually went a step ahead and came backwards. So we can see that this one would have to be a cosine squared. And remember, they're using x as a variable, so you have to put it in parentheses x. And then to get 1, this one would also have to be a cosine squared of x down here. So if this thing is over 1, right, that's why it's just sine squared, cosine squared. They got rid of the 1 in the denominator. Now, again, we're not sure what they want, so sine squared minus cosine squared. Well, they said, if you look, they left the cosine squared in the problem. So what's a way to break this up? And sine squared, what's another name for sine squared? It's 1 minus what? And so this is where I would put my cosine squared. And because it's a negative cosine squared and there's a negative cosine squared, that's how we end up with 2 cosine squares.